All right. Welcome, everyone. So, if you've ever found yourself digging into a legacy Delphi application, you know they're full of, well, let's call them secrets. Today, we're going to pull back the curtain on a really big one. We're talking about how a tiny choice, something as simple as how you store a list of items, can be secretly throttling your app's performance. Let's dive right in.
So let me just ask you this. What if the way you've been writing code, the standard patterns you use every day, are actually making your CPU's job a lot harder than it has to be? I mean, what if your code is literally fighting the hardware it's supposed to be running on? That's the kind of hidden bottleneck we're going to drag into the light today.
You know, it's funny. The biggest performance killers aren't always these super complex, hairy algorithms. Nope. A lot of the time, they're hiding right out in the open, in the most basic, fundamental parts of our code. We're talking about something as simple as how we manage a list of data. And it turns out, the standard way we've been taught to do this can create this massive, invisible anchor, just dragging our performance down.
Okay, so here it is, the heart of the issue. On one side, you have your standard collections. A lot of them are built on something called a linked list. Now imagine this as like trying to pack for a trip, but you put each sock, each shirt, each item in a separate box, and you just toss those boxes randomly all over a giant warehouse. It's a mess. Then, on the other side, you have high-performance collections. These guys are smart. They take all your stuff and put it neatly into one single suitcase, one contiguous block of memory. And believe me, that one little difference, it changes everything.
So, the big question is, how do we get that neat, organized suitcase instead of the scattered boxes? Well, in the Delphi world, a really popular answer is a library called Spring 4D. Think of it as a specialized toolkit packed with collections that were built from the ground up to solve exactly this kind of performance problem. It's all about giving you the right tool for the right job. So, inside the Spring 4D toolkit, you'll find some familiar friends, right? Things like stacks, queues, and dequeues. You've probably heard of these. A stack is last in, first out, like a pile of plates. A queue is first in, first out, just like a line at the bank. But here's the kicker. The magic isn't just in what they do. It's all about how they're built under the hood. Their internal design is completely different, and that's where all the speed comes from.
And here it is. This is the secret sauce, the big reveal. What's the foundation of these super-fast collections? It's not some complex, magical thing. It's something simple and elegant, a dynamic array. That's it. This one fundamental design choice is the reason they are just blazing fast. And it all boils down to how they cooperate with your computer's hardware, instead of fighting it.
Okay, so we've got our secret weapon, dynamic arrays. But why? Why does that matter so much? Well, now we're going to connect the dots and talk about raw speed. This is where we learn how to win what I call the cache game. And trust me, it's a game your code is playing with the CPU every single second, whether you realize it or not. So every single modern processor has this thing called a CPU cache. The absolute best way to think about it is like this. Imagine your CPU is a master craftsman. The cache is its tiny personal workbench right at its fingertips. Anything on that workbench it can grab and use instantly. But if it needs a tool or a piece of Word that's not on the workbench, well, it has to stop everything, walk all the way across the workshop to the big storage racks, that's your main memory, and go find it. The whole project just grinds to a halt.
And this is exactly the problem with those linked lists we talked about. They're like that chaotic workshop. They scatter your data all over the place, across that big, slow main memory. So to get anything done, the CPU has to go on this ridiculous scavenger hunt. Okay, I need item 1. Gotta run to the warehouse. Got it. Now, where's item 2? Oh, it's way over there. Run to the warehouse again. Each one of those trips is a cache miss, and it is an absolute performance nightmare.
But dynamic arrays, they are the complete opposite. They're like the perfectly organized craftsman. They put all the pieces you're going to need for a project right next to each other in one neat row. So when the CPU says, hey, I need the first piece, the hardware is smart. It sees all the other pieces right there and says, you know what? I'm just going to grab this whole block and put it on the workbench. And boom, just like that, everything the CPU needs is right there, instantly accessible. No more running back and forth. This right here is the big aha moment. This is what it means to write cache-friendly code.
Okay, so that's all the why behind it. The theory is cool, but what does this actually look like when you're writing code? Let's get practical. We're going to take a look at one of the simplest yet most powerful collections from Spring 4D, the iStack, and see just how easy it is to put all this speed to work for you.
All right, so an iStack. This is your classic last in, first out collection, or LIFO.
The plate analogy is perfect here. You have a stack of plates, you can only put a new plate on top of the stack, and you can only take a plate off the top. You can't just pull one out from the middle. That simple, strict rule makes it incredibly useful for a ton of common programming problems.
So how do you add a new plate to the stack? It couldn't be simpler. You just call stack.push and pass in your new item. That's it. The code is super clean, it's readable, and it does exactly what it says on the tin.
And taking an item off the top? Just as easy. You call stack.pop. It removes that top item and hands it back to you. It's just elegant. A really clean, minimal way to manage your data.
But here's the really crucial point, the main takeaway. Behind that beautiful, simple API with push and pop is all that raw power we were just talking about. It's backed by that super fast, cache-friendly, contiguous dynamic array. You get the best of both worlds, clean, easy-to-read code, and incredible performance. So if you remember one thing, make it this. When speed really matters, you should always reach for collections that keep memory together, not the ones that scatter it all over the place.
And look, this isn't just some deep-cut technical detail for the hardcore engineers. This matters for the whole team. For you engineers out there, this is your key to writing faster, smarter, more cache-friendly code. For you product owners and managers, this helps you understand one of the core factors that drives application performance and stability. And really, for everyone on the team, it's about seeing that something that looks like a tiny implementation detail, which list should I use, is actually a huge architectural decision.
So, as we wrap this up, I want to leave you with a question to take back with you. This whole idea, this principle of digging deeper and questioning the default choice, it goes way beyond just data collections. So I ask you, where else in your own code, in your own projects, is there a good enough solution that's secretly costing you performance? Go find it.